How are you? Good day, everyone. And we have to proceed with topic in Torsion. No? So we have next example. So we have two solid shapes, no, of different materials. They are rigidly attached together and attached at rigid supports as the figures yan, no. Now compute the maximum shearing stress developed in both shapes, no, or material used, no. Okay, so this is the figure, no. Now, there is an applied torque of 1 kilonewton meter. So, these two materials will actually offer resistance to this applied load, no? So, but only, we do not know, we are not given as to the value of the torques developed in steel and the aluminum. So, if we are required to give the maximum shearing stress for aluminum and steel, so you have to start with the value of this resisting torque, no? For aluminum and for steel. Okay, so we have to start with the equation of equilibrium now by just using the summation of moment or summation of torque. Okay? Now, by the way, we are provided with the answer. So, ours is only to verify. So, how to come up with those answers. No? Now, this is the required. And then, we have the equations of equilibrium. No? So, taking the summation of moment or summation of torque equal to 0. So, the resisting torque offered by the aluminum and steel will be equal to the applied torque, which is 1 kilonewton. 1 kilonewton is also good as 1,000 newton meter. Okay? Now, since these two are rigidly fastened, no, so that would mean that any twist in the aluminum, no, or any angle of twist in the aluminum will also be the same angle of twist that is experienced by the steel. No? So, we have the equations involving the angle of twist. No? So, angle of twist for the aluminum is equal to the angle of twist of the steel. Now, what is the formula for the angle of twist? No? So, we can recall. So, that is TL over the polar moment of inertia with a modulus of rigidity. So, we can now substitute to the formula. So, T for the aluminum. What is the length of the aluminum? 3 meters. No? So, by the way, if you have 3 meters here, no? What is important is that any unit placed on one side of the equation will also be the same unit on the other side. So, we don't need to convert. Okay? So, TA times 3 meters. So, TS times the length, which is 1.5 also in meter because the meter unit can just be eliminated naman. No? Okay, we have to consider the polar moment of inertia. The formula is pi over 32 times d to the fourth power. The diameter is also given. That is 75. Unit is in mm. No? So, 75 to the fourth power, mm to the fourth power. The modulus of rigidity is 28 gigapascal. So, I also put 28 gigapascal. Okay? So, on the other side, I also collected the given. The diameter is pilaman 50. And the modulus of rigidity is 83. So, with this, pwede na nimo ma-eliminated imuhang mga common. Okay, so we can remove m, we can remove giga, correct? We can remove millimeter to the fourth power. Now, including the constant, gini. Pi over 32, so, ayaw na nag-apila. Now, so, with that, pwede na ka mag-simplify. What is the value of TA? Okay, so, or we can just simplify, na? Okay, iniho na lang na ito para we're not going to solve for the value of TA. Instead, we have to form an equation on similar arrangement with the first equation. If I started with TA, so ako lang nang simplify 3 over the expression that is left. After removing this, so naapa ko 75 to the fourth power and 28 na. So, nabili na. Then, akong i-transpose because my TS is found at the left, no? So, minus TS, and I have 1.5, 50 to the fourth power, then 83. So, actually, I'm planning to use my calculator. I will be working with system of two unknowns, no? Okay, so, activating your calculator in system of two unknowns, no? Okay, so you can have on sa parirog x, y, then constant, no? X, y, then constant. Okay, so, input 1, 1, then 100. Equation number 2, you can input. Okay, so be careful with this. When you have 3 over, na, so you can put this into group. Okay, para the operation will be contained in the denominator side. Okay, then minus 1.5 over in group also, then equal to 0. When you press equals, now, so that's the time you can arrive with TA, which is your x, and you have your y, which is your TS. Now, so after knowing for the torque, So you can now proceed with the required shearing stress or a maximum shearing stress. Can you recall the formula for the maximum shearing stress? Okay, so we have pila to 16 T over filament to pi d cube when that is a solid shaft. Actually, these are solid shafts. No? Okay, so we can have the torque we obtain. Then we also have the stresses. No? So as per formula, so we have this. Then imo na lang i-substitute. No? So 16 TA, this one. So the unit is Newton meter, correct? And denominator, if you have to look at the denominator, we have pi d, 75 cube. So this is cubic millimeter. So if this is originally meter, that is why I need to convert my numerator in terms of millimeter. Para if that's millimeter, that is millimeter cube. So we can write it as millimeter squared in the denominator with Newton left in the numerator. So Newton millimeter squared per millimeter squared is good as megapascal. That is coming from the aluminum. So just do the same with the steel. No? So the steel, just substitute. We come up with this and we need to convert because we need to express this in Newton millimeter. Okay? And my denominator is millimeter cube. Substituting here the okay, there I come up with the maximum shearing stress. Now, so I pamilian na as I mas dako because when you are required to give the stresses, maximum shearing stresses, so just take their individual values. No? So, those are the answers for your stresses. Okay, so next problem. There is a steel shaft with a constant diameter of 60 millimeter. They are loaded with torques applied on gears attached to it as shown. No? So, modulus of rigidity, the same. No? Because it's made of the same material. Then, determine the relative angle of twist of gear D relative to A. Okay? So, this is the figure. No? So, these are the gears. No? Here's the boys. Gears. No? We have the gear here. No? And then, imong gibutangan og mga applied torque. Then, I torque here, which is, gana. Now, we got gear D relative to A. So, meaning, ari ka dire mag-view. No? Locking on gear D. Okay? So, what would be the angle of twist? Okay? So, an applied torque like this, now, may also be represented with a line with a head or a double or headed with a double arrow. No? Okay. So, pananglit, if we have to consider our diagram, so instead of having this, no, torque like that, so you can use like a force, but only it is headed with double arrow. So, 1,000 Newton, no? That is clockwise dire. So, ako lang ibutag to da, right? Pero you can also make nga to the left, basta imong timanan that is good for the torque, no? Now, kini, this is an opposing sense to 1,000. So, paingon sa left, no? So, we have also 1,000, same as the first, going right, then, yung So, if you really want to have a free body diagram, pwede ka mag-cut dire. Ari kung magsugod sa A, no? Cut mo na, and you have to show only this part, no? So, if this is the torque applied, so there is a resisting torque like that, no? So, if that is, counterclockwise, pero ari kung magtanaw dire sa pika side, so that is clockwise, kaya ari ka mag-view on the A padong sa D, so that is clockwise, then resisted with a counterclockwise, no? Torque. As the torque develop in segment, segment BA or EB. Okay? So, pero to avoid cutting section diha, no? So, nanad naman sa siguro ta itong maghimo ta og diagram or a load diagram. So, karon maghimo sa kog torque diagram. So, pareho lang ana. Badang atong i-plot our torques, no? Okay, pananglit ini. There is 800 Newton meter. No? So, panalitan ka clockwise. Ganyan mo na akong counter ni siya. Counterclockwise. No? So, ako lang ibutang og plus ni siya. Okay, counterclockwise. Okay, so due to this torque, so I have 800 Newton meter. Torque is applied here opposite to your 800, which is 1,000. So, sa ato pa, kung akong i-assume nga plus to ganina, kani mahimo siyang negative 1,000. So 800 as my reference minus pila to 1,000. There is a difference of minus 200 or a sum of minus 200. No? Okay, 800 plus a negative pila 1,000. Okay, bring that over the segment, and then there is a torque again on similar direction as 800. No, sa butang ni mo da. So, sa mani plus. Okay, so again, you have 1,000, then bring that over the segment, and there is an opposing sense, which is kine, so negative, negative man ni ganina, so negative 1,000, it will always close to the reference line. Okay, so muna na imuhang mga torque karan. Okay? So, actually, masa ito niya, this is counterclockwise man niya, no? Counterclockwise. Okay, so, ang atong pagkuha with the relative angle of twist, no? So, it's based from this formula. Only since we have different angle of twist in every segment, so the angle of twist is just a summation of the angle of twist per segment. Okay, so yun. Rotation of D relative to A. Okay, so it is, I put the product of polar moment of inertia and G, no? Because these two are constants. What varies are only the torque per segment and the length. Correct? Okay, so with this, pwede na ko mag-substitute, no? And I take summation, okay, of TL, no? So, 1 over, unsa man ni siya? This is for your J, kana. This is J. And this is the given, unsa? Modulus of rigidity. I express my polar moment of inertia is millimeter to the 4th power, then I just also have to make my G in megapascal. So 83 gigapascal man to ganina, so I make it megapascal. So 83,000 F megapascal. The TL, this is TL. Okay, so diri ko nagsugod sa left, no? Naman to 1,000. Yeah, positive man to, no? So we have times 3 the length, then minus pila? 200. Then plus another 800 times 2. This is a unit of Newton meter. This is meter. So that's why every term has a unit of Newton millimeter squared. No? So to go with the unit of millimeter squared there, no? So this is already reduced. That is millimeter squared. So akong ibutag millimeter squared because the angle must be made unitless. No? Okay, so that is the conversion. Okay, so all units are eliminated and I come up with the value. Okay, so the positive result means a counterclockwise angle, no? So, because if you have to view it from A, looking at D, so it would be counterclockwise rotation or twist, no? So, region, anyway, there is no unit indicated, no? So, it can be accepted as an answer, but if ever you are required to give the answer in terms of degree, so you can convert that to degree. With a conversion factor, 180 degrees is to pi regions, no? Then we can have 6.82 degrees as answer. So that's your number 2. So dali ra, no? Okay, this one. This is different. This is another one, no? Actually, it's not different, no? The positioning lang of our torques or our load, no? So a hollow bronze shaft, 3 inches outer diameter. So this is hollow, no? With an inner diameter of 2 inches. Slip over a steel shaft, no? So there is steel shaft that is placed within its inner diameter, which is hollow, di ba? So, and of the same length as the hollow shaft. The two shafts are then fastened together rigidly at their ends, no? So, if the modulus of rigidity for bronze is given, then this is also given for steel. Water can be applied to the composite shaft without exceeding a shearing stress of 8,000 psi for bronze and 12 psi for steel. So required is the applied torque. Okay? So it is like this, no? So this is the length. So this is the steel that is placed on the hollow part of your bronze, no? So this is a shaft, circular in form if we have to view it at its section, no? So these are the modulus of rigidity. These are the allowable stresses, now as mentioned in the problem. Okay? Now again, if the torque is like that, we can also represent this with a katong ito. Pwede na to ibutang o line headed with a double arrow. Now, in order to find out or in order to look at the internal resisting torque for steel and bronze, no? Then simply cut, no? So, magpaano rin na ng free body diagram because it is there where we can see the internal effect of your torque or externally applied force or torque, no? Or loads, no? Okay, so when we cut it, okay, no? So this is the applied torque. Okay, balance with that one, no? Okay, then if I have to view the left in part, no? So, this is the applied torque and it's resisted internally by the two materials. So, this is coming from the bronze and you have the steel. Now, ningon ko ganina nga torque, no? On a notation like this, maybe unsa represented with a line headed with double arrows, no? Okay, ngini. So, yan na. So, I may have, actually, different direction, maybe taken, padong diha, basta, kung imong gigamit counterclockwise, padong ingana ba, or clockwise, so, because kung doon ay opposite direction of movement, then, make it opposite. Okay? So, at equation of equilibrium, no, the applied torque must be equal to their sum, no? Okay, so we have on that. TB plus TS is equal to the applied torque, no? O sa itong required in what do we need? The value of the applied torque. Now, it's possible to have this, now, if we have the value of TB and on that TS, no? Okay? But if we cannot have the value of TS and TB directly, so there is also an allowable shearing stress that is given, no? Okay, ngini. So, when they are rigidly attached, no? So, it means any twist on the bronze and in the steel, the twist must be made the same because they are fastened together rigidly. Okay, so we can have the formula. Okay, so we can substitute, no? So, we have TB, L, the same length man di ba? Okay, then we have pi over 32. We have this, okay? We simply substitute. This is the outer diameter for the bronze man di ba? Then, doon na siya modulus of rigidity. This is the inner. Okay, then at the speakers, we have TS, L, di ba? Okay, so nga na. So, when that is simplified, no, just to show you that I'm eliminating what is common, both sides of the equation, so wala na. Correct? PSI as a unit, wala na. The unit, even kini, wala mo na 10 to the power 6, wala na. Okay? So, including tanang mga common on both sides of the equation, when it is simplified, no, TB may be defined in terms of TS or TS may be defined in terms of TB. So, nakabot tag-ingon ana. Now, what is the use of this? I want to go back with this one. Now, maybe my TB and TS may be expressed in terms, imon ba na ako na puros TB, then I can have my T in terms of TB, I can have my T in terms of TS. Okay, so, ato ni kopyahon on the next slide. Okay, nga na. TB as defined is equal to this. Okay, then I can consider my first equation. Asa naman to? Kini. Suppose my TB is replaced in terms of TS. This one, ako ilisan. Pulin ako there. Okay, so what is the resulting equation? This one. We have what's that? TB, this one, 65 over 32 TS plus TS. So if you combine this to, so 65 over 32 plus 1. This is 1, nah? Or 32 over 32. So 32 plus 67, that will give you that. That will give you pila man. That will give you 97 over 32 TS, correct? So your TS in terms of TS, 32 over 97. Do the same with, kung akong gamiton kini, mo akong himuna kong TB, so ang TS mo, ako ipulihan ako ngana. Okay? So I can go with the first equation. TB akong gi-retain, o niya, ang TS akong gilisan og TB. Okay, ngana. So this is 1 man so 65 over 65, correct? Okay, so that's 97 over 65. So that is, pila to? 97 over 65 TB. So TB in terms of TS, 65 over 97. Okay? So with this, now, so magkuha na ko sa atong gamito na ko to, I have to use the allowable shearing stresses. Okay? Allowable shearing stresses from steel. Okay, so allowable shearing stress for steel. As a solid shaft, no, ang steel, maumantong nasa middle, so maximum is 16T over pi d cube. The allowable is 12 KSI, correct? So 12,000. Kay KSI man to, di ba? That's equal to 610. O niya, sa steel, steel is 32 over 97, expressed in terms of T. Actually, with this equation, what is left as the only unknown is T. So, mag-solve kog T out from steel, and I also have to solve for T out from the bronze. Okay, so we have T, which is, okay, but this is only a possible value. The unit is pound, correct, and inches. No? So, that is pound ends, correct? Okay. Then, adto sa das, allowable stress for the, sa bronze. But your bronze is hollow. Okay, that is why the formula for hollow is, kini. We have the formula, never forget the formula. 16T for bronze, then diameter, then pi. So, outside diameter in the 4th degree, then minus D to the 4th power inside diameter. Okay? So, we can now substitute. The allowable is, pila man tong sa bronze. I think, pila? 8? Yes. 8 PSI, 8,000 PSI. Okay, so there you have, no? Then, 16 TB, asa man TB na rin. Okay, so 65 over 97 in terms of T. Then the length of which is 3 diameter, not the length, no? So this is, diameter is 3 inches outside, Then pi, outside diameter, the inside diameter is the diameter of your steel shaft, that is 2. Okay, so units, this becomes cube. There is a square here, so what is the unit left is inch, no? So pound inch. So there I have another value. Comparing the two values as answer, now basta load gani imong pangitaon, you must go for the maximum load capacity for the two shafts, no? You must go with the smaller one, no? To make it safe. Pero dimension gani imong pangitaon sa to, adto ka sa mas dako nga value. Okay, load gani ari ka sa mas gamay. So your answer will follow nga this is the answer. That is 50.789. But we can also convert this in terms of pound-foot, no? So if this is inches, so we just divide with pila? 12, and I arrive with this one, so this is pound-foot. Okay? So simple as that, no? Balik-balik lang, na? Now, the next problem, we deal with problem involving power, na? So, power can be converted also in terms of torque, no? So previously, our given are all unsa puros mga torque daan, no? So karon we are given a power. There is a steel marine propeller transmitting 4.5 megawatts at 3 revolutions per second without exceeding a stress of 50 megapascal or a twisting. Sa duha ka condition, dapat mo satisfy with the allowable stress and the allowable twist, which is not more than 1 degree in a length of 25 diameter. Actually, the diameter here is not mentioned, but niingon lang siya nga unsa. In terms of 25 of the diameter is the length, because what is needed is really the diameter. We are provided with answer. Ours is to verify. Okay? So, marine propeller. Okay? That one. Ngita tag figure nga propeller. The length is 25D. The diameter is D. Okay? It is transmitting power. What is the power? 4.5 megawatts. No? Okay, there is a frequency of 3 revolution per second. Okay, convert your power to torque on it. Okay? So, these are the allowables in finding your D, allowable stress, allowable twist. Okay? Then, power, torque from power. So, what is the formula? Power is equal to torque times the angular speed. No? But, the angular speed can be reduced in terms of frequency. Okay? I'm substituting the value given. P is 4.5 megawatts. Watts means Newton meter per second. Ang mega is 10 to power 6. So, 4.5, this is mega, this is watts. Okay? Then, T is the unknown, or T mo itong solbon, para we can have it be substituted later in finding the required D. Okay? So, 2 pi means per revolution. Because we have a frequency of 3 revolution per second. So, this is out. So, per second, it's out. So, the unit for torque will be Newton meter. Evaluating this, you come up with the value, Newton meter. If you want to make it Newton millimeter, just multiply by 1,000. Just move to the right 3 decimal places. Okay? That is if you want to have your T in terms of Newton millimeter. Okay, or you may have that and just convert when it is needed. Okay, so I have to consider the allowable shearing stress. Okay, so I have this. Allowable shearing stress is, it should not be more than 50 megapascal. Okay, so I have to maximize using 50 megapascal. Okay, or Newton per square millimeter. 16T, this is the value we obtained kanina, but this is Newton meter. If I want to make it millimeter, so what is mentioned kanina is to multiply by 1,000 because meter squared is out and this is millimeter. Okay, so simplifying, we obtain a value for D. So, dimension for the diameter, and they have two possible values because you are also given an allowable twist. The allowable twist, if considered, the twist must be not more than 1 degree for a length of 25D. Okay? So, formula for twist, atong i-consider. So, theta, with T, L, siya? J, and modulus of rigidity. Okay, so 1 degree and 1 degree to radian. Okay, and we have the torque. In terms of Newton millimeter, it's multiplied with 1,000. The length is 25D. This is, moment of inertia, polar moment of inertia, 1/32, D to the 4th power. Okay, then we have 83,000 megapascal. 83 gigapascal is 83,000 megapascal. For the units, wala na ning meter, so Newton millimeter, correct? What else? Newton millimeter, may nahabilin. And Newton is out also. This is per millimeter squared, so that can be taken as millimeter cube, Your D is reduced, and this becomes D cube. That is why the unit for millimeter is millimeter cube, So that's why when we take a cube root, then you will arrive with a value, which is in mm. Okay? So we have two values to consider. These are dimensions of the diameter, so you must go with the shape, which is the bigger value. That is the proper diameter to be used as answer. Okay, so we're almost over. Last, ato ni apilon There is a steel shaft, 3 revolutions per second as frequency, with 30 kilowatt taken off at A, then 15 kilowatt removed. They are the same, It's both are being removed, Then remove at B, and 45 kilowatt applied at C. If G is equal to 83 gigapascal, what is the maximum shearing stress and the angle of rotation of the gear, So which means kana, may atong pangsulbon, Okay, so steel shaft. Okay, ngayon atong figure. Okay. So, proceed na. So, mo ni imong mga gears, And there is an amount of power being taken off here in the 2 gears, So, naabay pump diha, So, reducing the power dire. Okay, so, power is also applied dire. Okay. So, what are the maximum shearing stress, The maximum shearing stress, dili ra sa answer, You can use both, You can evaluate both, Kay lain-lain mo na siya nga segment, Okay, so angle of twist of gear A. So, first, atong kuhaon what are the equivalent torque from power. At A, unsa man itong formula, power over frequency, over angular speed, So, in terms of frequency. So, 30 kilowatt, So, kung that is kilowatt, so, kilonewton, So, that is 30,000 newton meter per second. 2 pi, so, per revolution is 2 pi in radian, So, we have 3 revolutions per second as given. So, I obtain a torque in newton meter at A. So, do the same with B. I substitute, okay? No problem with substitution. That is 50, that's 30. So, it will follow nga half, mo gawas. Then, kini, we have at the 45, sayop. This is 45, ha? So, 45. Okay, sayop na. Copy mo good. Paste, no? Okay, so 45. So, if that's 45, so, this is thrice in, or just divide 45,000 divided by this, no? Then we can arrive with this one. So, they are the torques, no? So, if they are the torques, so pwede na ito ibutang katong dunay line with headed with a double arrow, no? Okay, like that, no? So, these are, torques, no? Removed, no? Or power being removed, so producing a torque, and this is being applied, no? Now, if you have to go with the angle at gear A and gear C, so ganina, we plotted directly, naghimo ta ko sa ito, naghimo ta o torque diagram. As alternate, you can also go with cutting section. Yan. Okay? So, pananglit. I have to consider my torque. Okay? So, by taking a free body diagram, okay? So, akong gikat dere. Na? So, just to show you a different approach, no? When it is cut, no? So, kaning akong torque padong dito, akong i-counteran o gingon ana. This torque is due to a power applied. Murag clockwise mo to. Okay na. Sa ito pa counter na siya. Correct? Okay. So, we have clockwise. So, okay na. Counterclockwise. Okay. Then, we have a value. That to must be equal by inspection, no? So, for equilibrium condition. And then, I again have to cut that, no? So, this is my cutting section. I have two torques, no? We have the applied. We have the torque from the remove power. Okay? So, to balance, so kini mas dako man eh. So, this is 795. So, I need this much, no? So, on the same direction as this. So, sa ato pa, they are all counterclockwise torques, no? Then, pwede na ka magkuha sa imuhang sa maximum shearing stress, no? O, imo lang na i-substitute, no? So, actually, in segment EB, the value is pila? Asa man ang EB? This one? So, it is 64.85. In segment BC, if you substitute, where is BC, so kani imong gamiton. So, ang EB kana sa imong gamitan. Then, we substitute values. Lain-lain diameter, ha? Ang EB doon ay diameter nga 50, ang PCAS doon ay 75. When evaluated, so we come up with stresses, no? So, most stress ang AB. Pero just give the two as answers. Anyway, lain-lain man siya nga segment. No? So, we have 64.85 megapascal for EB. So, most stress ang AB. Okay? Now, how about the angle of twist? Anyway, wa mo tayo problema sa twisting anuman. Puros man ni sila counterclockwise. Pero if one is counterclockwise, the other one is opposite sense, no? Or say clockwise, no? That's the time you have to consider the signs, no? Counterclockwise, positive ba? Ang usa, negative. So, imo na i-consider. Pero, all counterclockwise, so sa ado pa, ang imo karon nga twist will also be counterclockwise twist. Okay, so, ingin 1 over G. I did not put my J together with the modulus of rigidity because the materials are the same. So, parehas ang modulus of rigidity, but ang imong J have different diameters man. So, ako siyang iipon together with this variable TL. Okay, per segment. Okay, so we have a unit. So, Newton millimeter squared for your modulus of rigidity. T and L. Masabi itong T and L. T, asa man 1.5 na rin. 1.5 sa AB. Then, times a length of 4. No? Given man 4. Then, kini is the polar moment of inertia, 50 man na. So, we have this. Then, plus kay puros mo sila counter. Pero, kung counter ni kini clockwise, so, ako sa imong ibutang negative. Ang yan, timan niya, asa imong negative, ang counter ba or ang clockwise. Okay, puros positive, so the result must be counterclockwise, no? By the way, the unit here left is, o sama itong unit? The unit left here is Newton meter squared, correct? Okay, so ang meter squared, ako imong millimeter squared. Okay? Because if that's the case, nga millimeter squared, nga naman, kini millimeter to what power man ni siya? fourth power man eh. So millimeter squared ginam sa kay millimeter squared, millimeter to the fourth power millimeter squared. So mahimo ni siyang millimeter squared or square millimeter in the denominator, so that unit millimeter squared can be removed. Newton will be out because if that's an angle that is in radian. So kay radian man, we can also go with degree. And tingnan nga, this is a result out from a counterclockwise twist from from C, observing your gear at A. Okay? So, that's how to solve problems involving torsion. So, for now, that is the end of the topic. Okay? So, thank you.